How do we convert integrals then into the sigma notation? So we have our integral here, we have our beginning and end points, we have the function part of the integral, and then we have the dx part of the integral. And we need to relate all those parts into this general expression for the limit form of the sigma notation limit form of the integral. We have a k equals 1 start, we have an n endpoint, we have the function part of that expression, and then we have the I over n, or interval width over n, which then represents the dx part of the expression. So we can establish that the interval width divided by n is going to be our dx. So in this case, our interval width is going to be from 3 to 5. So our interval width is going to be 2. And then we divide that interval width by the number of divisions, or n, and that gives us the dx, the width of each dx in that integral. The function part of this is going to be the x4. So we can see that that's the function part. That's going to be the x4. So we need a function part of this limit notation, or this sigma notation. So then we need to, once we establish those two parts, we can see that we're going to start at 1 to n. We have our dx part, which is going to end up being the interval width over n. And the function part is going to be some power of 4. We need an x in there. The x is the k over n part of the expression. And we need something in here to make this work for x equals 3 to 5. Okay, so we need to figure out what that part is to get the proper numbers into this sigma notation. So we want the bound, so notice the bound here, we want to start at 3, and since k starts at 1, if k equals 1 and n equals infinity, right, we're going to end up with some number plus essentially 0, and that's going to give us a starting point in here is going to be equal to 3. So we need to then figure out what this question mark part of it is to establish the starting point of 3. Well, to do that, we really just need to start with 3 and add 0, give us 3. So that is where this 3 here in blue comes from. Okay. We must end at x equals 5, so we have to show this. This has to be reflected in the n value when we substitute k is infinity, n is infinity, so this essentially is 1. This needs to reflect that we can go from 3 to 5. Well, if we add 2, we're going to get to 5. So that it shows up as this end point here. This is going to be reflected in the end point. So now we have all the parts we need. We end up with our beginning and end parts. Okay, the beginning and end parts also reflected inside the function to establish the values that we're going to plug into here. We have the function part. That's fairly straightforward because if we establish the function in the integral, that same function has to show up in the limit form of this sigma notation. The dx, just be careful. We can't just assume it's always going to be 1 over n, because the dx is going to be the interval width divided by n.